Okay. ठीक है। ये चार डिफरेंट लगाया क्या?
हेलो, गुड आफ्टरनून एवरीवन। आई होप सब लोग मुझे सुन पा रहे हैं। ओके, सो लेट्स स्टार्ट विथ टुडेज क्लास। So once again, everyone, welcome to Avanti class. So this is our fourth class of organic chemistry. ठीक, so myself Lakshman, and let's start the class. ठीक है? Okay. So which other thing today we are going to discuss? आज हम इन चीजों को डिस्कस करेंगे। ठीक है, तो पहला है कि we will see the hyperconjugation. ठीक है, after that we will see the aromaticity. ठीक है, हम क्या क्या देखेंगे? So today we are going to see this. So welcome everyone to Avanti class. Okay, so this is our fourth class. ठीक, so today we are going to discuss about these are the thing today we are going to discuss. ठीक है, तो हम पहले क्या देखेंगे? So first we will see hyperconjugation, फिर हम देखेंगे resonance, फिर we will see the aromaticity. ठीक है, so these are the thing today we are going to discuss. ठीक, ओके, सो लेट्स सी वन बाय वन। सो तीन चीजों का हम डिस्कस करेंगे। सो पहला वाला हमारा क्या है? हाइपरकॉन्जुगेशन। लाइक जिसे हम करते हैं, तो फर्स्ट व्हाट विल डू, विल फर्स्ट सी द रिकॉल, हमने क्या क्या पढ़ा है, जो विल डिस्कस द प्रीवियस क्लास लेक्चर जो है। ठीक है, तो उसके बेस में ट्राई टू सॉल्व दिस वन। ठीक है, अभी ये क्वेश्चन है कि हमारा इनमें से कौन ज्यादा एसिडिक है, व्हिच इज मोर एसिडिक अमंग दिस। ठीक है, हमें देखना है ये इन दोनों में सबसे ज्यादा एसिडिक कौन है। ठीक है, तो फर्स्ट वन दिस, तो एसिडिक किसको कहा जाता है? जो H प्लस देता है। तो हम देखते हैं हाउ विल सी द डिसाइड द स्टेबिलिटी और मोर एसिडिक अमंग दिस। तो हम क्या करेंगे? पहले H प्लस को दे देते हैं, फिर सी द स्टेबिलिटी हम क्या करेंगे? ये H2 है। ठीक है, आफ्टर दैट ये F है, एंड वी हैव दिस वन CO माइनस। इसके बाद ये होगा CH3 एंड CO माइनस। ठीक है, अभी देखो हमें पता है व्हेनेवर यू हैव नेगेटिव चार्ज वो कैसे स्टेबलाइज होगा? इफ यू हैव इलेक्ट्रॉन विथड्रॉइंग ग्रुप, जो अगर माइनस आई इफेक्ट से वर्क कर रहा है, इन दैट केस वी कैन सी ये ज्यादा स्टेबलाइज होगा। ओके, सो बिकॉज ऑफ दैट, बिकॉज इट कैन पुल द इलेक्ट्रॉन डेंसिटी टुवर्ड इटसेल्फ। फ्लोरीन हाई इलेक्ट्रोनेगेटिविटी है। ठीक है, इसलिए हम इसे बोल सकते हैं दिस इज मोर इलेक्ट्रोनेगेटिविटी कंपेयर्ड टू दिस वन। ठीक है, इसके वजह से हम बोल सकते हैं ये मोर स्टेबल होगा इसके रेस्पेक्ट में, और वी कैन से इट कैन डोनेट H प्लस इजिली। दैट इज वी कैन से ये वाला पहला वाला जो होगा दैट इज मोर एसिडिक कंपेयर टू द अदर वन। तो हम बोल सकते हैं ये तुम्हारा ज्यादा एसिडिक है कंपेयर टू दिस वन। क्यों? बिकॉज आफ्टर डोनेटिंग H प्लस इट कैन इजीली स्टेबलाइज द एनायन। ठीक है, इसीलिए। ठीक, थोड़ा सा यूट्यूब में लाइव जा नहीं पा रहे। ओके, ठीक है, अब नेक्स्ट आप देखते हैं अमंग दिस व्हिच इज बेसिक इन नेचर। ठीक है, तो पहला वाला हो गया, सेकेंड वाला विल सी। ओके, अमंग दिस व्हिच वन इज मोर बेसिक? हमारे पास से एमोनिया है। ठीक है, एमोनिया है, आफ्टर दैट विल हैव मिथाइलिन, फिर ये तुम्हारा डाइमिथाइलिन। विल सी अमंग दिस व्हिच इज वन इज मोर बेसिक। बेसिक का मतलब क्या होता है? इलेक्ट्रॉन डोनर, जो इलेक्ट्रॉन डोनेट कर सकता है, दैट इज कॉल्ड दैट नेगेटिव। ठीक है, दोज आर कॉल्ड गुड बेस, जो तुम्हारा बेसिक नेचर ज्यादा होगा। ठीक है, सो विल हैव लोन पेयर हियर, लोन पेयर हियर, लोन पेयर हियर। तो देखो इट कैन डोनेट लोन पेयर। ये लोन पेयर कब डोनेट कर सकता है? जब इसका टेंडेंसी ज्यादा, हमारा उसके पास ज्यादा इलेक्ट्रॉन होगा। कब इलेक्ट्रॉन ज्यादा होगा? व्हेन देयर इज सम ग्रुप व्हिच कैन पुश द इलेक्ट्रॉन टुवर्ड इटसेल्फ। ये इसमें देखो ये दो इलेक्ट्रॉन दे रहे हैं, तो इसमें इलेक्ट्रॉन डेंसिटी ज्यादा हो जाएगा। ठीक है, और इट कैन इजीली डोनेट द इलेक्ट्रॉन। हम इसमें देख सकते हैं, ठीक है, इसमें कोई ऐसा ग्रुप नहीं है which can help this nitrogen to donate electron, बट इसमें तुम्हारा क्या है, it has one methyl group which can donate the electron density to nitrogen because of प्लस आई इफेक्ट, इसके लिए इसको ज्यादा इलेक्ट्रॉन होगा, सो इट कैन इजीली डोनेट द इलेक्ट्रॉन। ठीक है, तो इसका मतलब ऐसा, इफ यू सी द बेसिक स्ट्रेंथ, इसका ज्यादा है तो वी कैन से इसका सबसे लीस्ट होगा, फिर इसका होगा, बिकॉज टू मिथाइल ग्रुप, इसमें टू मिथाइल ग्रुप है, इसलिए इसका ज्यादा होगा। एवरीवन अंडरस्टूड दिस, ये सभी को समझ में आया? ठीक है, सो लेट्स प्रोसीड। ठीक है, चलो हम आगे बढ़ते हैं फिर। ठीक है, इसका हम देखेंगे कल क्या क्या पढ़ा हमने, कुछ रिएजेंट के बारे में पढ़ा, जैसे वी हैव स्टडीड द एसिड, एसिड के बारे में पढ़ा, व्हाट इज एसिड, व्हिच इज दोज आर द प्रोटॉन डोनर, वो प्रोटॉन डोनेट कर सकते हैं। ठीक है, इफ दैट इज मोर स्टेबल, ठीक है, अगर उनका जो कॉन्जुगेट बेस अगर ज्यादा स्टेबल है, देन वी कैन से दैट इज अ स्ट्रांग एसिड। ऐसे बेस बेस क्या होते हैं, व्हिच कैन एक्सेप्ट दैट H प्लस, या तो व्हिच कैन डोनेट इलेक्ट्रॉन, दोज आर कॉल्ड बेस। ठीक है, एसिड में तुम्हारा क्या होगा, व्हिच कैन एक्सेप्ट द इलेक्ट्रॉन पेयर ऑल्सो, अगर इलेक्ट्रॉन पेयर को एक्सेप्ट कर सकते हैं, ठीक है, इनको एसिड कहा जाता है, बस वो लुईस एसिड होगा। ठीक है, ये थोड़ा सा डिफरेंस है इसके
So again, sorry for the interruption. Actually, YouTube live was not working. That's why the things were discussing the things. So now, moving further, 18 and 18 meter per second. Find the velocity of the third particle. Can I say that initial momentum is conserved and initial momentum will remain equals to the final momentum? So this is our initial condition. Initially, momentum is 0. So the final momentum will also be 0. Now, or you can say three parts: small m, and 3m. Net momentum should be 0. What I am saying, net momentum of these three balls should be 0. So we need to calculate momentum here. Listen to me very carefully. Can you see that momentum of this first ball is mass into velocity? Can you say that P1 is equals to mass into velocity? Can you again say that P2 is equals to mass into velocity? Two momentum perpendicular to each other, making an angle 90 degree with each other. In the vectors chapter, you have studied that when two equal vectors are perpendicular to each other, then their resultant is what? Then their resultant is what? You will say the resultant of these two vectors, I am naming it P1, 2. P1, 2 means P1 and P2, resultant of P1 and P2. What will be the value of P1 and P2? I am writing here. You all know that when two vectors are equal and perpendicular to each other, then their resultant is multiplied by the root 2 vector. So it will be root 2 into m into 18. This is a simple thing. I think you know that as b square 2ab cos theta. So theta is 90 here. So it will come under root a square plus b square. I know you are aware of that. And these two vectors, the resultant of these two vectors is along this direction and the angle will be bisected 45 degree. I hope you have studied vectors very well. So now what I am saying, for the net momentum to be 0, the third part must have the momentum opposite to the previous one. So the third part or third ball should have momentum in this direction. This is very P1 and P2 are along this direction. Then P3 must be along this direction, so that net momentum should be 0. So for net momentum to be 0, P3 should be equals to P1, so P3 is mass, which is 3m. Let's say its velocity is v, is equals to root 2m into 18. Can you solve this? M got cancelled. So v is equals to 6 root 2 meter per second. I think the answer you got was 6 meter per second. Can you find the error in your solution? What was the error? The net velocity or the velocity of the third part is 6 root 2 meter per second. Along which direction? Along this direction. Can you find the direction? This angle is 45. This angle is 90. So the angle is 135 degree from x-axis. This is the initial momentum is equals to final momentum. I have applied it. Final momentum you can calculate by any method. That's up to you. Have a look at that question. Now I am moving further. Okay. Okay, now one more thing that I want to ask you. Do you know about the relative velocity? Just say me yes or relative velocity of A with respect to V, kind of AB equals to what is the VAB equal? Do you know anything about this term? Velocity of A with respect to V. Just say yes or no. So now the question says someone replied, no, sir. Okay. Let me tell you. Let me tell you. Just let me explain in a moment. I will delete this portion because it will take a lot of time. For example, this is a car. I have drawn it wrong. Let's say this is a car A and this is another car B. This car is moving with velocity something you can say 2 meter per second. B is moving with 4 meter per second. So someone may ask you, what is the velocity of car A with respect to car B? The velocity of one moving object with respect to the other object is called relative velocity. As simple as that. Here two bodies are moving, then the relative velocity, velocity of A with respect to B can be called as velocity of A with respect to ground minus velocity of B with respect to ground. This is the formula that you can use for the relative velocity. Again, I am saying velocity of AB can be written as A with respect to ground minus B with respect to ground. For example, if I say you need to write velocity of P with respect to Q, then how would you write that? Velocity of first is written as P with respect to ground minus velocity of Q with respect to ground. Can you expand this formula now? Are you learning? Are you getting the point? If I say velocity of man with respect to plank, I want to write velocity of man with respect to plank, I want to write. So then you will write velocity of man with respect to ground minus velocity of plank with respect to ground. The way I am pronouncing it, you should understand it in that way only. Velocity of P with respect to Q, P with respect to ground, Q with respect to ground. The term written first should be written first here. The term written second should be written second here. And there must be a negative sign in that. Just learn about that. Further things we will discuss later if we got a chance to discuss the things. So till then, I am erasing. You can summarize the things that relative velocity is the velocity of a moving object with respect to the other moving object. So now the question says, first of all, we need to understand the question. The question is saying that initially both were at rest. I mean the plant and the man both were at rest. Now the man starts walking with a velocity. What you need to do, determine the velocity of the plank with respect to. Now the thing is, the velocity u is given with respect to the plank, and you were asked to determine the velocity of the plank with respect to the ground. what we can do here, if I choose man and plank as a system, man and plank as a system, then there is no horizontal force, no external force in the horizontal direction. So the momentum will remain conserved. Momentum will remain. But what I need to do is, can you imagine if the man is going forward direction, then the plank will go in the backward direction. This surface is smooth. This surface is smooth. So if the man moves forward, the plank will move backwards. So we need to calculate that velocity. Thing is, when you are applying conservation of momentum, then the velocities that you are taking with respect to one frame only, like if you are choosing all the velocities ground frame, then all velocities should be in the frame of ground. If you are choosing all velocities from the plank frame, then all velocities should be in plank. Let's take ground as the frame because we were asked to answer the question about ground. So I am writing few terms for you. Let velocity of man with respect to ground. This term is representing velocity of man with respect to ground. This is a question and you should know these questions. Again, velocity of plank with respect to ground. What does this term represent? Velocity of plank with respect to ground. Next term is that I am going to use velocity of man with respect to plank. Velocity of man with respect to plank. Can you answer which velocity out of these three is given to you and which were asked to you? Can you identify? Let's say this is 1, this is 2, this is 3. Which one is given to you and which one is asked from you? Can you answer one in terms of 1, 2, and 3? If anyone is understanding the things, then he might answer. My first question is, which one is given to you? Which one is given to you?
It is given.
Okay. Okay. You were given, like here, velocity u with respect to the plank. That means velocity of man with respect to plank is given. And you were asked velocity of plank with respect to the ground. Velocity of plank with respect to the ground. This one is asked from you. Is this thing clear to you? Now what I have explained you previously, velocity of man with respect to plank can be written as velocity of man with respect to ground minus velocity of plank with respect to ground. Don't get confused. The first term, the second term, and the negative sign. That's what I have told you. This is the easiest way to remember the equation. Now, I have told you that make all array. That's why I am calculating velocity of man with respect to ground. This term I am calculating, it will become, transferring it here, VMP plus VPG. Let's make it equation number 1. Now I am applying conservation of momentum. Now applying conservation of momentum. From conservation of momentum. Momentum means P. What we can write from that conservation of momentum? P initial is equals to P final. What is the value of P initial? You will say that man starts walking. Starts walking means initially he was at rest. If the man was at rest, then Planck was also at rest. So initial momentum is 0. Is equals to final momentum. Final momentum is what? You will say finally man mass m is moving with velocity vmg, because I am writing all the velocity in terms of ground frame. So this is the man and velocity of man with respect to ground. So this is the momentum of the man plus the momentum of the plank. Momentum of the plank means mass of the plank is capital M into velocity of the plank with respect to ground. All initially everything was at rest. Finally, man was moving in velocity, plank was also moving. So I have written the momentum of man and the momentum of plank and velocity terms ground plane. Okay, now you can place the values. I have calculated the velocity of man with respect to ground. That is written here. You can place this value VMP plus VPG plus MVPG. Can anyone see that velocity of man with respect to Planck? This term, man with respect to Planck, is given as what? U. I am transferring these values towards the left side. So what it will become, if I open the bracket, m into VMP, it will go to the left, so it will become minus m. Velocity of man with respect to Planck is u, is equals to velocity of PG will be common here. VPG is common. What is left behind? M plus capital M. So velocity of Planck with respect to ground is written. What can you write here? Velocity of Planck with respect to ground is minus mu divided by m plus m. This is your answer. What does this minus sign signify? This minus sign signifies that Planck is moving towards left direction, towards negative x direction. I have told you previous concept. Have a look at the question, have a look at the solution, and ask me if you have. I have chosen two questions. You are not preparing for the board exams, and I want you to learn something new every class. So that's why a bit higher level question is there. So now moving further, with your permission, moving further. I'm very clear of this term actually. Every time we see some collisions, when we play cricket, when we play football, every time there is a collision happening there. This remove everything in front of you, just Be focused. Look at me. Look at your screen. Nothing should. So like something in front of you. For example, अच्छा, definition of that na collision is what? This is what collision. Okay. So let's say this is a ball. Let's name it ball A. And there is another ball. Name it as B. So what I am saying, ball A is moving with certain velocity u1 and ball B is moving with a certain velocity u2. And you all know that if they are moving in same direction and we want them to collide, then u1 must be greater than u2 now. u1 is coming from behind. Then for the collision to happen, u1 must be running faster. So that collision will happen. This is the initial situation. This is what? Initial situation. Now, A will collide with B. So there is a situation of during the collision. So we need to understand that situation as well. Let's say when is by cricket with some ping pong kind of ball or some some balls, you hit the ball with the bat. This compression in not that visible. Actually, everybody gets deformed. So when they collide, actually, there might be or there will be a compression in the bodies. So this is body A, which gets compressed or it gets deformed. Its shape is deformed. Similar thing happens with ball B. It also gets deformed. Now, when these balls get deformed, you have studied, you know about a tendency that body their shape, their shape generally. Ideally, there might be some bodies like plastic bodies that we call that don't have a tendency to regain their shape. But if I talk about in general, then every body has a tendency to regain their shape. So what will happen in that case if this regain? This ball will push these push is fed by B. You can say acting on those bodies will be like opposite to each other. Can you see that velocity of A by the force of B? So what I am saying that velocity of A will decrease and velocity of B will increase. And the process continues. What will happen again? At the time of each and everything here, at the time of maximum compression, or you can say deformation, at the time of maximum compression, here their velocities become equal. here. What happens? They get deformed due to they are ball behind gets decreasing and the ball ahead gets increasing. So at a particular situation, both the velocities become equal. At a situation when compression was met. Now, after that, the final situation came in which ball A might or be in its shape, or you can say ball might regain their shape, might not regain their shape. Two things may happen. Two things may, but I am taking the general case. I am taking the general case. When it has regained its shape partially and ball B also regained its shape partially. Partially regained. So now, suppose after the collision, they have a velocity v1 and v2 respectively. Initially, their velocities were u1 and u2. Finally, their velocities are v1 and v2. And in between, during the collision, their velocities are v. When a, can you say that have press the gains some potential energy, its potential energy increase. Energy was half x square the previous chapter. Energy was known as potential energy. Potential energy ball was pressed, some of its kinetic energy but clear. Same thing happens with ball B. Kinetic energy also gets converted into potential. So one thing, another thing that we need to remember is due to the deformation, some kinetic energy is transformed into potential energy. Very get clear. Now again, when they regain their shape completely, like suppose if they have regained their shape completely, they become the same as before. Then their energy that was stored due to the deformation, again lost. Again lost means gain energy. So what I am saying, if body the get body gets deformed, it when body doesn't deform, overall conclusion is that in some situations, kinetic energy may be lost. In some situations, kinetic energy may not be lost. So depending on the type of body, loss kinetic energy, whether it's loss, there is a loss of kinetic energy or whether there is a no loss of kinetic energy, things happen. For example, elastic collision. There are three types of collision that we are going to study. That one is elastic collision, in which bodies regain their shapes. That's what regain their shapes. The bodies regain their shapes. That means the important point that you need to remember. What are the important aspects at this situation is no loss of kinetic energy. Why there is no loss of kinetic energy? Because the loss in the form of deformation is regained. Get bodies regain their shape, and no deformation left. No deformation, differential energy. Another thing, during the collision, all the forces are internal to the system. So momentum is conserved. Momentum is conserved. These are the two important things. Another important thing, this is the result that you need to remember. I formula of this collision in your classroom. So I am just putting the result here. Velocity of separation will be equals to the velocity of approach. Now just answer me. Have you heard these terms? Have you heard these terms, velocity of separation and velocity of approach? Do you know these terms, or I need to explain these terms? Let me know in 1 second so that I can explain these terms. Otherwise, I will move further. Do you know these terms or not? Just answer me very quickly. Velocity of separation and velocity of approach. Okay. I hope everyone knows these. Know these terms. Yes, everyone knows. Okay. So in elastic collision, what do you need to know? There is no loss of kinetic energy, momentum is conserved, and velocity of separation is equal to velocity of approach. Another term is perfectly inelastic collision. Perfectly inelastic collision means bodies do not regain their shape. Bodies do not even try to regain their shape. They are actually not trying to regain their shape. So when they are not trying, so what might happen? They stick together and move. One thing is that what will happen? Collision is inelastic, they will stick together and move. That is one thing. They are moving together. Can you say that they will have same velocity? They will have same velocity. This is the another thing. Now, next thing is, I'm again saying, whenever collision happens, there is no external force acting on the system, then momentum is conserved. Momentum is conserved. Another thing, can you answer that body doesn't get their shape? Body doesn't regain their shape. Does it mean that they have some potential energy stored in itself? If they have some potential energy stored in itself, then can you say that that kinetic energy might be increasing or might decrease? So there is a loss of kinetic energy in the process. The process. Again, can you say that what about velocity of separation? They are actually not separating after the collision. So velocity of separation is zero. Again, you can conclude from here. Velocity of separation is zero. Velocity of separation is zero. There is another real life collision situation which is neither perfectly elastic nor perfectly inelastic. That is somewhere inelastic. Partial inelastic, you can say. Partial inelastic bodies regain their shape but not completely actually. Some deformation is remaining in the bodies. If some deformation is remaining in the bodies, then what we can conclude? One thing that you need to know, momentum is conserved. On the next slide, there is a question for you. Momentum is conserved. The next point is, can you answer that kinetic energy is lost or not? Whether kinetic energy is lost or not in the process? Can you answer? Shape completely restore नहीं हुई है. Shape was not completely restored. So what does that mean? They have some potential energy. Now, there is a smaller potential energy stored in there. So where does that potential energy came? It came from kinetic energy. So what can you write? Small amount of kinetic energy is lost. Another thing is velocity of separation is equals to E times velocity of approach, where E is the coefficient of restitution. You will come to know about these points very soon. Momentum is conserved, a small amount of kinetic energy is lost, velocity of separation equals to E times velocity of approach. Just remember these key. There is a concept test ahead of you. What you need to do, you just need to answer those questions very quickly. I am putting those questions in front of you. Just try to. In the case of oblique collision, that's not for you. It will be uh, than the principle for you. So just move further. Take a concept test. Okay. Question A, B, C, or which one is correct? Anyone? Pune, Wardha, Rajkot. Anyone?
C.
What does question says? In elastic collision. This is not complete word. In elastic, not. This is in elastic collision. They are talking about elastic collision. First statement says momentum does not remain conserved. Can you say that momentum is always conserved in the collision? So this statement is wrong. Second statement says only momentum remains conserved. Third says both momentum and kinetic energy remains conserved. And fourth says neither momentum nor kinetic. Fourth is again clearly wrong because it's saying neither momentum. Now fight is between B and C only. Collision or perfectly elastic collision, bodies completely regain their shape. They regain their shape when there is no potential left. No potential left means against the option C is correct. Both momentum and kinetic energy remains. And one more thing, just that you need to notice here. I am just telling you one thing. This is very important thing that I want to clear in you. Three situations were there. Initial, during collision, and after collision. Now, what is the meaning of conservation? What is the meaning of conservation? That at situation 1, situation 2, and situation 3, in all these three situations, kinetic energy must be same. Then we will say kinetic energy is conserved. You getting my point? Repeating my words. There were three situations. One is before collision, one is during collision, one is after collision. And third means all. What can I say? During the collision, some kinetic energy is lost in the form of energy. So we can conclude that kinetic energy is not conserved. Kinetic energy initial is equals to kinetic energy final. But kinetic energy is not conserved in the process because it has some lower value during the collision. Are you getting my point? In collision, it is not. I hope this point is pretty much clear in your mind. So you cannot say kinetic energy remains conserved. So this statement is again wrong. What is the meaning? Say initial is equal to K final. But during this time, some kinetic energy is lost. Statement B is true. Only statement B is in elastic. Yes, Meena, can you answer?
Sir, I think D.
Kinetic energy is not conserved. Both momentum and kinetic energy is not conserved. Momentum is conserved. So again, option B is momentum is conserved during all the process. Third question. Can you answer this question? In an elastic collision, the initial kinetic energy is equal to the final kinetic energy. First statement. Second is the final kinetic energy is less than initial kinetic energy. Kinetic energy remains constant. Kinetic energy first increases, then decreases. Decays. Which one is true? Again, kinetic energy does not remain conserved. What I have told you. Kinetic energy remains constant. No, it just not remains. I think this is the first concept question that I told you. So the right answer is the initial kinetic energy is equal to the final kinetic energy. K initial is equal to K final. That's what the true answer. I am moving further. Or we can include one more elastic collision. Very close to that's what exactly velocity of separation is equal to velocity of both. Velocity of both and the ball perfectly bodies and move together. Is it clear? Section. Let's solve few questions. This is a class quiz for you. And first question on your screen. This is previous year question of JEE mains. This is previous year question of JEE mains exam. Let's solve this question. If you want me to discuss the question, from my side, please, very quickly. You need to answer very quickly. What is the meaning? What does this question says? This is a platform on a smooth platform on blocks A, B, C are kept at rest. Masses are mentioned here. A is given the velocity V. And we are saying each collision is perfectly inelastic. Inelastic means they will stick together. Perfectly elastic means they will stick together. Sacrifices of which initial kinetic energy is lost in the process. Complete. How many collisions will be there? First, A will collide with B, then B will collide with C, or you can say A will combine with collide with C. So in the whole process, six of initial kinetic energy is lost. Right? How will you solve that? Solution. I am saying that during the collision, momentum will remain conserved. Momentum will remain conserved. And can I say that after final situation or final collision, these three blocks will stick together and will be moving with the same velocity because they are stick together and will be moving with the same velocity. Let's suppose that velocity is v dash. Let's suppose that velocity is v dash. Their masses are m, and capital M. This is clear to you. Now what I am saying, from conservation of momentum, what we can write, P initial is equals to P final. Initially, only A has some velocity. So mass of M into V is equals to P final means all these masses. What is the value of total mass? 2m plus m, and total velocity is V dash. Let it be equation number first. Can you calculate the velocity V dash from here? V dash is equals to mv divided by 2m plus m. Now, the another statement is 5 by 6 of total kinetic energy is lost. 5 by 6 is lost. Then remaining energy is sorry. If I say initial kinetic energy and final kinetic energy, if I write the ratio, and I'm saying initial kinetic energy is 1 joule because no value is given, so I can take initial kinetic energy is 1 joule. Then final kinetic energy will be 5 by 6 is lost. Remaining is 1 by 6, na? So 1 by 6. Can we further write that K initial is equals to 6 times of K final? The value K initial is what? Half small m. Initial is what? Only this block was moving. All other blocks were at rest. Half mv square is equals to final kinetic energy is half. Total mass finally is 2m plus m into v dash square. You can again put the values half m v square is equals to half. Can we cancel half from here? We can cancel half now. Half is cancelled by half is equals to 2m plus m. The value of v dash is written here. What we need to do, v dash is square. So I am squaring it straight away. That will be m square v square divided by 2m plus m whole square. So can you solve it further? V square get cancelled. V square will get cancelled. M will get cancelled by m. And this 2m plus m cancelled by the square. So what is left behind? 1 is equals to m divided by 2m plus m. Now you can again solve this. Cross multiply it. 2m plus m is equals to small m. Is there something missing in it? Okay. 1 is equals to m divided by 2m plus m. So 2m plus m is equals to m. I think there is something is missing in it. Okay, I have missed this sixth term here. We have missed this sixth term here. So 6 can be written here, here. And 6 can be written here, here. Okay. So you can say m is equals to 4m. So m by m is equals to 4. This is okay.
Sir,
Okay, say something.
can I ask one doubt?
Okay, sure, definitely. Sure, you can.
Sir, right side, second
Right side.
step.
Okay, this one.
Yes, sir.
Okay. What I have did, I just did calculation part. This m square or this m is cancelled by the m square. V square is got cancelled by this one. 2m plus m divided by 2m plus m squared. So this square is cancelled by 2m plus m. On the LHS, nothing is left except 1. If you cancel everything, then it will be 1. On the RHS side, there is 6 left, a small m left, and on the denominator, there is 2m plus m. So this is left. So we just got cancelled, something cancelled in the then RHS side, from the LHS and RHS side. That's what we have done.
Then how this RHS came?
How this RHS, okay, very good. So RHS was we were writing final kinetic energy of this system. And finally, all these masses were stick together. So total, what is the kinetic energy into p square? Total mass is what? 2m plus capital M. This is what the total mass. And what is the velocity? Is v dash. So half total mass is 2m plus m multiplied by velocity square. So this velocity v dash is calculated here. So I just put the value of v dash in this term. And after squaring, because we need to square the v dash now, after squaring, we are getting this term m square, v square, 2m plus m whole square. This is the value of v dash square that we have placed here. This is the term that was this term. I think I have
It's okay, sir.
one question that you can solve in the homework, and it's in question as I solved it here. This is again mains question and recent mains question. I think 2021 or 2020 something. This is, came in 2021, I think. I don't know the year, but you can solve this question. This is quite easy question, and you can easily solve this question. Initially, all the blocks were at rest, and then A is given some velocity 9 meter per second. You need to calculate final velocity of C. Conditions here. So I'm ending the session here. In the next class, we will start rotational motion. It's going to be this is a very hot